So functions. The top of the page on page 16, there's a box there that kind of defines what a function is, and then I'll kind of clarify that a little bit. So in that box, there's a function is any rule, like an equation or a table of values, right? It's a rule about a relationship between x's and y's, right? That assigns exactly one output, right? And the outputs would be the y values, right, for each input. And the inputs would be the x values. That makes sense, right? Because usually when you have an equation, you input some x value, and the output is the y, right? So you can express these functions in different ways, right? We can use equations, graphs, tables, okay? Now, another word for the input of the x value, and you need to know these, would be the independent variable, right? Because it can be anything you like. It doesn't depend on anything. And another name for the output of the y would be the dependent variable, right? Which makes sense because the value of y depends on what? When you have an equation like y equals 5x plus 3, what does that value of y depend on?
It depends on the x.
Whatever x you put in there, right? Okay? So let me do this. Maybe this will clarify. Let's make a little note on that blank page. All right, so let's go over to page 17 real quick. So a function, just to clarify, okay? So a function is a relationship where each output, or each input, I should say, each input or x value, right? Or we would call that the independent variable. Has exactly one output, okay? Each input has exactly one output or y value or dependent variable, okay? And I'll draw a quick graph here, right? And you have your x and y axis, okay? So if I draw something like this, here's my x-axis or my input values, right? And the y-axis would be the output, okay? So this is output. And down here would be the inputs on this axis, okay? And so maybe I have something like this. Maybe it's a parabola, right? Okay. Now, would you agree that as I look at that graph, that every x value, every input along this axis, does it have any more than one output up here on the graph? Take a look at that graph. Can you see that every single x value on that x-axis has only one y value that goes with it? Like if I pick this x value here, whatever it is, it only has one y value right here, doesn't it?
Yeah.
Okay? And any x value, as I move left and right on that x-axis, whichever one you pick has only got one output value of y, right? And this parabola, right, it's a collection of x comma y's, right? Otherwise known as input comma output, right? Or you could call it independent comma dependent, right? They all refer to the same thing, x's and y's, right? So now if you have a graph, I think you learned in algebra to determine whether it's a function, there's a certain test. Does anybody remember that test to see if a graph is a function?
The straight line test.
Okay, straight line, but a little more specific than straight. Because I mean, all lines are straight technically, right? But a little more than straight. What would you say? Somebody's got to remember.
The vertical.
There we go. We'd have the vertical line test. Okay. So if a vertical line can intersect a graph more than once, would it be a function? Think about that graph we have over there. If it intersects your graph more than one time, do you have a function or not a function?
Not a function.
Not a function, right? Not a function. Okay? So if we take a look at this graph over here, pick somewhere to draw a vertical line. And how many times, pretty much no matter where I draw that vertical line, how many times will it intersect that graph?
Once.
So is this graph a function?
Yeah.
It is a function. All right. And maybe I'll give you an example of one that's not a function to kind of jar your memory here. So let me go down here a bit. So let me draw another one. Let me draw the inverse of that parabola. There's my X input, there's my Y output. Maybe I have this. So will the graph of that be a function?
No.
No, right? So this is not a function. All right. So let's take an X value. Let's take this X value right here, whatever the number is, right? If we go up here, you see that has an output up there, okay? A Y value output up there, and it also has another output down there, okay? So that violates the exactly one output for each input thing, right? So this relationship is not a function. So you all remember that, hopefully, okay? I know we kind of covered that in algebra. All right, let's go back. Everybody have that? Is it copied down? All right, well, if not, it'll be online too. So let's go back here. Page 16, look at example 1. And they give us a couple of graphs here, okay? One looks like an ellipse, and then another parabola. It says one of the following graphs shows a relationship where y is a function of x and one does not, okay? In part A, they want us to draw a vertical line whose equation is x equals 3. Now, I hope you remember what the graph of that line looks like. Some of you have had me in class before. The way I always remember what kind of line that is I ask, x equals 3, what axis does it cut through? But the hint is what I just circled.
The x-axis.
The x-axis, and where on the x-axis does it cut?
3n.
At 3, right? So I'm going to go out on the x-axis at 1, 2, 3, right? And I'm going to draw the graph of the line x equals 3. Okay? So that's a vertical line whose equation is x equals 3, because everywhere on it, the x value is 3. Okay. So we've intersected the graph of that with the line x equals 3, right? And in part B, they want us to give all output values for an input of 3, okay? So let's go over here to 3, all right? I think we have to draw that same line in B. Let's go down to, let's go down here to graph B, relationship B. draw that same x equals 3. 1, 2, 3, right? So this one. There's x equals 3. All right, so let's make sure we have that. Now, up here, relationship A. For an input of 3, okay, what is one of the outputs?
One of the outputs is 4.
Okay, so we have a ordered pair of 3 input, comma 4 output. What is the other output for that input of 3?
-4.
Negative 4. So is this a function?
No.
No, because, well, there's a vertical line hitting it twice. Well, but why does that work, right? Because if you look at our ordered pairs here, you see these inputs of 3? How many outputs does 3 have?
We has 2.
So it has 2 outputs, right, for input of 3. Okay, and that's why the vertical line test works. Now let's look at relationship B. For an input of 3, what is the only value for an output?
-2.
Negative 2 down here, right? This stupid, hang on, stand by. I'm having these glitchy things that were supposed to be fixed. All right. So for an input of 3, the only output is -2. Okay? So there is only one output for input of 3. Okay? So then in part C, which one of these is a function and why? A or B?
Relationship B.
Okay, so B is a function. Because why? Every input has what?
1 output.
There we go. Every input or X value has exactly 1 output, right? Right by the definition. Or Y. Okay? Now A is not a function, right? A is not a function. Because why?
It has 2 inputs.
No, you can have a billion inputs, right? It's the other way.
Outputs or another.
For the same input, right? So because an input of 3, an input X of 3 has 2 outputs. And there's more than just that too, by the way, but that's the one they had us pick. It has 2 outputs. Or Y values. Okay? So that's not too hard, right? That's a little bit, you guys pretty much covered that in algebra way back a couple years ago. It's just a review, right? And I think the next thing we do, I don't know if you covered one-to-one functions. Did you do that in algebra? Like you did the vertical line test for functions. Do you remember the term one-to-one functions?
No.
Okay. All right, so that's going to be our lesson 2. So let me stop this video here.